Okay, so this week we're finally getting down to our weather in our area. So, what are the mid latitude weathers we deal with? We talked about the planetary circulations last week. Well, in the mid latitudes, we're kind of between 30 degrees north and 60 or so degrees north. So, our weather is coming out of the west typically, and it's controlled by fronts. Well, fronts are the boundary line between two types of air masses. So if we look at our surface weather map here just quickly, this is really cold air up here and very, very dry. You think about it, a dew point of minus 29, minus 24 degree temperatures. That is extremely dry, very cold air. The edge of that is coming through Ohio into western Kentucky, western West Virginia right now. It's dividing temperatures that are in the teens back here, or even lower. Temperatures out in front of it are in the 40s. Oh yeah, there was another cold front. This thing has 3 different cold fronts with it, each one changing the wind direction and cooling it off. So they're very touchy air masses here. And finally, you can see out ahead of this one, temperatures are in the 60s. Then they drop off into the 40s, and then they drop off all the way back into the 20s. So I would argue that there may not be quite as easily defined these 3 different fronts, but you can really see here with this front. Look at the strong gradient we have here, very strong winds. Low pressure is kind of trying to form, or is up in here to an extent. So we're pulling down. These cold fronts are moving through. Out ahead of them, there's probably a warm front out here over the ocean somewhere that we're not seeing. Or you can see a small one here coming into the west coast of the United States. And right now, none of these are occluded fronts. We have some stationary fronts along the Rockies. If you think about it, the cold air is coming down out of Canada, hitting the Rockies. If it doesn't get up and over those Rockies, that cold air, that front's stationary. And that happens a lot in the wintertime, where you wind up with these fronts coming down and just kind of align with the eastern side of the Rocky Mountains. So, but there are source regions for these air masses. You think about it, cold, dry air, where's it going to come from for the United States? It's coming from Canada, Alaska, even the Arctic. Where would a moist tropical air mass come from? Well, think about it. 30 degrees north, we have highs. Well, that's right over the tropical ocean or the Gulf of Mexico. So that's going to be where the moist, warm air comes from, coming up out of that area. The dry, warm air, well, we have a desert here in the southwest of the United States. It doesn't get a lot of precip, kind of between the mountains to the west and the mountains to the east. So it's kind of blocked from where it can get much precip. That's where our dry heat comes from. And finally, if you're looking for cool but moist, think about the northern Atlantic or the northern Pacific. Even much of the Pacific's relatively cool as far as us, the United States, goes. So those are source regions for where these type of air masses come from. So you can kind of look at, that's where the frontal boundaries are going to begin to move from. When I'm looking in the wintertime and I want to know if it's going to get cold at my house, I'm kind of looking at how the air is doing up in Alaska and Canada, how cold it is, where the front is, it's up here, and is that front being pushed southward? So you can actually see all this when you look at a satellite picture. We have a lot of clouds over the eastern United States right now. You can actually see out here, there's a front, another one back in here. Oh yeah, the low pressure is kind of forming right in this area with little swirls of the clouds. And then on the west coast, you can see, look at all the fog along the west coast, because we have a cold air mass out over cold water there, moist. Maybe that is a maritime polar air mass. You can see, you can tell a lot from satellites and combine it with your surface weather maps. Finally, everything's controlled somewhat by a jet streak or jet streams. These flow from west to east across the United States. We've talked about them having zonal flow or meridional flow. Meridional flow is when they tend to dig down into the United States, go way down even into Florida sometimes. And this one's doing. You can see it's really coming down south, really going back to the north. So this is a meridional flow for a jet stream. Oh yeah, they kind of divide the cold air too. So the greatest temperature gradient, if you were to work your way up in the atmosphere, is right along where this jet is the strongest. So they provide, you can actually tell the colder air is on the north side of this jet, and the warmer air is typically on the south side of the jet. Go back to our surface weather map. Kind of gives you that picture. Warmer air here. Oh yeah, there's a slight slope. Remember, the warm air is going to ride up and over the cold air, so that jet streak would be a little bit to the east of that. And you go to the east, you have low pressure, cold front well out off the coast. Low pressure up in here, cold front well off the coast, you have your jet streak here. So these do a great job of depicting where the fronts are. Remember, fronts do slope, so you got to think about that when you're looking at where the jet streak would be. Now, if we were to look down to 500 millibar, we would see here actually a closed low over the eastern United States right now. And that corresponds very well with this low clouds and all here. Very cold air, aloft. We're getting March sun now, even late March sun, so it's fairly warm. So it's trying to heat up the ground more. What happens is you get lots of convection, like we had earlier, except not as strong as where you had the big thunderstorms and all earlier in the week. But you wind up with a lot of clouds, literally self-destructive sunshine, where it's fairly cold aloft like this, and there's just a little bit of moisture, which there is here. You wind up with getting all these clouds. So now let's just take a quick peek. We just talked about the air masses here. And we can move on quickly to the next one. We talked about how the modified air masses, as they move over the ground, are going to change. Once they get away from the source regions where they form, they're going to transition into something gradually modified. That's why in the wintertime, when you think about it, Arctic air coming out of Canada brings really cold air to the northernmost North Dakota area. And maybe there's snow cover up there, so it stays the same. But by the time maybe it gets down to Ohio or into West Virginia sometimes, that snow cover might have disappeared. So that has modified some. And guess what? When it gets even further down into the east, on this side of the mountains where I live, it's even modified more because we don't have a lot of snow cover on this side of the mountains typically. Maritime tropical air masses, however, they come in off the water. They can stay quite warm as they're moving north because of the sun. Now, again, they're going to modify very quickly if they hit snow areas, but they tend to modify less. And here you can see the slopes. Warm air is always going to be rising up over the cold air. So a stationary front like we saw, if you were to be flying into it, you might hit cirrus at first as you're flying across. Then the clouds will get lower. And as you get close to the front, warm air is just beginning to be lifted right there. You might have low cloud stratus, fog, rain. Warm fronts, typically the same thing as it's moving east. Cold fronts, much steeper. Remember, cold air is very dense, so it's going to be very steep. So it tends to push into more thunderstorms. Occluded fronts, on the other hand, when a cold front gets faster, there's a warm front out ahead of it, and actually overtakes that warm air. What's going to happen? The warm air is going to be lifted aloft. So you wind up with the warmer air aloft. And yes, this is a cold front that's moving in, but the air ahead of it's now relatively cool as well. So a cold occlusion is when the air to the moving in is colder than the air that it's replacing. Whereas a cool occlusion would be the air coming in is not as cold as the air as it's replacing. But both cases, it's pushed the warm air aloft. So that's an occluded front. And here you can see the Norwegian cyclone model. What happens is, we've talked about jet streaks and divergence aloft, and typically there is some kind of front. The United States has different predominant areas. You might have a front along the Rocky Mountains. You might have one coming out of Canada. Sometimes the Gulf Stream has lifted some moisture north along the east coast of the United States. That's why we get nor'easters. And when that jet streak crosses that boundary, what happens is you get a lift, and that begins to form low pressure. Low pressure means convergence. Well, guess what? That's causing frontogenesis. It's actually increasing the strength of that front. So as that happens, you wind up getting a stronger low, more of a jet streak, and it's like a feedback process on itself to eventually you wind up with an occluded front, comma head shaped clouds where the cool air from the east is sliding across that area, forming the comma head. So here you can see the incipient cyclone, the wave as it's developing. Many times it only gets that far. It may not even get to a closed low, especially if you have zonal flow across the United States. But if it does start getting to that point, it could go all the way to an occlusion. And I want you to notice this little area here, a triple point. You have an occluded front, a warm front, and a cold front. Many times, a second low may form, and this happens along the eastern part of the United States frequently, that favors the new cyclone development, and this may become the predominant low, especially by the time that we get up into New England. Here you can see a conveyor belt model. What we're trying to do is track the different types of air masses, literally within this model. Cold air mass coming down, drying, sinking behind the front. Warm conveyor belt, maybe coming up out of the Gulf of Mexico, even the Caribbean Ocean. And there's that cold conveyor belt coming up and around high pressure, usually to the northeast of the low. But that cold conveyor belt is lifted as it's coming into the storm because of all that divergence aloft. And it is what pushes the clouds to the west and causes the comma head, whereas the warm air comes up into it. But you can see here the dry air coming down from the west, sinking, may form a dry slot in the low. Maybe that ends the precipitation very quickly sometimes. Precipitation types vary significantly around these extratropical cyclones. Notice I use the word extratropical. That's because these are not tropical cyclones. These form across the United States all the time. We have them all year round. And sometimes tropical cyclones can transition into extratropical cyclones, but not all the time. So what happens is you wind up with a warm sector and a cold sector. Warm sector, you may have fairly mild temperatures. You may also have maybe better chance of thunderstorms. Conditions are more ideal where you have warm air. On the cold side, well, maybe you have some snow or even freezing rain. If you have warm air riding over it, maybe some of that warm air is warm enough to actually cause some freezing rain. And if you're looking for where it's going to move, you look for the rising pressures behind the low, falling pressures ahead of the low. And oh yeah, there is one unusual case. I'll just mention it. If the pressures are actually falling slightly behind the low and falling more ahead of it, that low is really deepening very fast so that the pressures don't have time to rise behind it. They're actually the low is getting so deep so quickly. And here you can see some different tracks of lows. And cold core. We talked about it earlier when I showed you the thing. The pressure falls very rapidly in cold air aloft. That means that the pressure lines are going to dip down. The 300 millibar surface is going to be lower. It actually also means, when we looked at planetary circulations, you saw how the tropopause kind of buckled in the mid-latitudes. Well, if you have a very strong extratropical cyclone, the tropopause is going to actually drop down fairly low. So that's why there's some discontinuity to tropopauses in this part of the world. And here you can see the non-occluded one, weaker, more zonal flow, but still pressures are dropped more fast in the cold air behind the low. Now, in the summertime, and even in the wintertime, sometimes there can be warm core cyclones. What happens, for example, is the desert Southwest. Maybe it gets intense heating. Temperatures get well up into the 100, 110 degree range. What happens is we know that the warmer the temperature, the air becomes less dense, and that less density, it spreads out, and you wind up with lower pressure there. However, because you have lower pressure at the surface and it's very warm air, we know that as you go aloft, the pressure is not going to drop as fast. You wind up with higher pressure aloft. So you actually may have an anticyclone over these thermal lows. We have warm core anticyclones and cold core anticyclones. And here are some other types of circulations, a little smaller scale, such as a sea breeze. If you went to Lake Erie, you would feel a sea breeze many times, or one of the lakes. And you can come down to my area. I went down to the beach this week. When I first got there, it was 74 degrees at the ocean front. When I left an hour later, it was 62 degrees. Why is that? A sea breeze developed. Valley and mountain breezes. You have these in West Virginia, all over the place. And depending on the sunshine, think about it. The sun hits. Where is it warming? That's going to warm the mountain slopes first. The air gets lighter, tends to rise over the mountain slopes. So the air from the valley begins to rise up the mountain, come back down. In the wintertime, well, we know we have cold air drainage. So where's the cold air going to wind up? Down in the valleys. If you go up to Elkins, West Virginia, go to their airport and look around it. Their airport is located in a big valley. When I used to forecast in West Virginia, that area had some of the coldest temperatures in the state consistently, especially when it was clear and calm. Why is that? The slopes on the mountain cooled. The air flowed down into the airport area there in the valley, and it continued to cool. It doesn't stop cooling, so that we had some of the coldest temperatures around in that area, all because of a mountain breeze. Chinooks occur out the west mainly, but we can get them in the east coming down off the Appalachian Mountains. And a Chinook is actually what occurs with the Santa Ana wind that causes extreme fire dangers in the Los Angeles area. Hababs are just dust storms. They form when you have strong thunderstorms in the desert Southwest, pushing air down. You may not even have any rain coming down because the air dries out there. It's so dry. But you may have a lot of very cold air sinking, hitting the ground, lifting the dust up, and you wind up getting all that dust coming out ahead. Notice the slope here to the darker clouds. That's because the winds at the ground are moving faster than the winds above it, because they're hitting the ground and getting spread out. The more slope, the stronger the wind. Heat burst. I've only ever been in one of these, and that was in Oklahoma City one time when I was there for a course. What happens is you get a strong thunderstorm that has developed, and as it's moved, it's hit drier and drier air, especially in the low levels. So what happens is the air that's come down out of that thunderstorm, and it's coming down dry adiabatically because the air has, all the evaporation has occurred, continues to the ground where it went up moist adiabatic. Now it came down dry adiabatic. It actually gains temperature, and you can get temperatures rising from the 70s and 80s. When I was there, I got up to 101 degrees in Oklahoma City in the middle of the evening with this. So this is really what I wanted to talk about. If you have any questions, let me know.